You guys did really well with the reading on that part A1. And what I was going to do is try to give you a couple examples of different ways that we use the distributive property that will also help you with your homework. So, in looking at this, it says the distributive property helps with multiplying for sure. You're going to use it a lot and finding the area of rectangles, but it's also a good brain exercise in doing a problem more than one way. So kind of like what we just talked about, that problem A1, this is similar to problem A1. Actually, all of part A. So the only thing that we didn't really do when we looked at that was you didn't do this formally, like what would your homework look like. So when you look at a problem like this, and it asks you to show two different ways to calculate the area of the rectangle, not only do you have to be able to do it in your head, but I want you to be able to write it out. So I could kind of model that. From what you guys told me, well, let me ask you this. How many, raise your hand if you can tell me how many rectangles you see. How many do you see, Zoe?
I see, well, there's 6 on the, like, lengthwise.
Just like in the picture.
Oh, in the picture.
How many rectangles? 2. How many do you see, Anastasia? 2. Anderson?
1, because 1 is
No squares there. Because one side's 6 and one side's 7. And a square is a type of rectangle. Michael?
I see.
Jay, what do you see?
2,
Naomi?
3.
3. JT?
3.
Avi? Oh, 2. How many? 2. Isa?
3.
3. Okay, Michael, where are the 3? Describe the 3 to me.
Well, there are 2 on the inside.
Okay,
Those 2 together.
so if you look at this, there is this rectangle, and then there's also this rectangle, and then there's also this whole rectangle. Okay, and the reason that's an important question, I want you to think about that question when you think about the different ways you can find the area of the whole big rectangle. You could do it in parts, using parts, or you could do it with the whole big rectangle. Okay? So in your homework, that's one of your jobs today. So that green rectangle has a distance from here to here that is 6. Do you see that? How far is it across? What goes here?
7.
7, right? And I'm going to add that area to this pink rectangle, which, what number goes at the bottom? 5. And on the side? 6. So you might notice that I wrote down method 1 and method 2. It's because the book, and I'm going to do the same thing, we wanted to see if you could find the area of this big rectangle 2 different ways. So one way is to break it into smaller parts. So I could say 6 times 7 plus 6 times 5 would give me the area of the whole rectangle, because 6 times 7 is 42. What's 6 times 5, Andrea? 30. And then if you add those together, Andrea, 42 and 30, what do you get? 72. And since this is an area problem, we're going to say it's 72 square units. You should put in units. If it asks for area, yes. Let me shrink that up a little bit. Do you still see that back there? Okay. So to figure out how long this is, what 2 numbers do I need to add?
7 and 5.
Right. So the other method looks a little weird. This is still 6, but the other method would be showing this with parentheses and the distributive property like this. 6 times whatever 7 plus 5 is. That's method 2. So it's basically saying add 7 plus 5 first. So Jay, what is 7 plus 5?
7 plus 5. So here's what I would do it in, since I know that 7 plus 3 is 10.
Yep.
And then do
Perfect. So 7 plus 5 is 12. So my first step is to write it like that, and my second step is to write it with the 12, and then 6 times 12 is 72, right, good job. And what do you notice about the answers? Why?
It's the same method.
They're different methods, but these two rectangles together make that whole one, didn't they?
Yeah.
Right? So they should be the same, and that's how you're going to be checking your work is you want to make sure that you end up with the same answer on a problem like this. That's good. They should be. Okay? Give me a thumbs up if you get that, thumbs down if you don't. Sideways if you're kind of not sure. Okay. That's not bad. Couple downs. Stay with me if you have a thumbs down and see if I could do this differently, okay? So I want you to look at the picture on the left. See if you could maybe see how if I think of these as numbers in boxes, if we could go and figure out the boxes here. You can work with somebody next to you. So I'm going to pause this. I want you to figure out what numbers go into this box, and this box. And if you really didn't understand the first part, I want somebody next to you to try to help you. Okay. So he just said he saw that 7 was in both the common numbers, so he put it in the big box.
So I put 7 in the big box, and then I put 5 and 4 in both of the boxes.
So because this looks a lot like that picture on the left, right? So you have the 5 here.
Yes, and then 4 there.
And the 4 there. Ooh, and my pen's not putting, it's not working, it's supposed to be in the box.
Okay. So then I did 7 times 5, which got
To check that makes sense, right? So now you're gonna do 7 times 5 and you get
35.
35. And then you're gonna do 7 times
4,
and you get
28,
28. And 28 and 35, what should those add to?
1600.
You guys see that?
Yeah. Yeah.
So it's just kind of like a brain teaser. But it also, later in math, it's a great tool to do mental math, even though today you might not understand why. Let's have a different person kind of think about this one. So it's kind of going backwards, ID.
I think you would,
So I'm going to be honest with you, the picture is not great. Like the line, it should really look more like, while you're thinking, like, let me fix that picture. The picture should really look more like that.
Okay, that makes sense.
Is that better? Was that bugging you guys? Yeah.
I was confused.
Understood. Okay, so ID, what would you do?
So, you would put the 3 on the last one,
Uh-huh.
and then you would put,
Like right here?
yeah,
Okay.
you would put, 10 for the next one.
Right here?
Yeah. Yeah. And
Let's
then-
put that coin away.
And then you'd have 5 right there,
And right there.
because it doesn't change.
Okay, because it doesn't change, what do you mean by that?
Like, 5, the only number that can be there is the number that it doesn't change throughout the rectangle.
Okay, it's common to both,
Yeah.
right? So,
It's not parentheses.
yes, it's outside the parentheses, so how would you check? Let's work this out. What's 10 plus 3?
13.
13, right? And what's 5 times 13?
65.
What is it?
65.
65, right? So if I work this out, oh man, these pens, the orientation's not great. If I work that out, I should get 65. Sorry about that. I think the board is just having a little brain trauma right now. So 13 times 5, 65. And then Ideen, how could you check that with what you have? What goes here?
5 times 10 is 50.
5 times 10, right? And that's 50.
And then 5 times 3 is 15. So that was kind of what I was talking about. Like, it works with 5 times 10, and then it goes to 5 times 3. It's
Right.
not like a different number, like 6 times 3, and not 5 times 3.
Right. They're the same. The 5 is part of both, so that's why it's on this side. Abby.
It's sort of like breaking like a huge number. Like,
It's exactly like breaking a huge number up because when you do a huge number, that's how you would use this. You'll hear me do this a lot. If I said like what's this isn't huge, but if I said what's 7 times 49, I'll ask you guys what is 7 times 40 and what is 7 times 9? What is 7 times 40? 280, right? And what's 7 times 9?
63.
63, and you'll get really good where you can add that in your head. So that's distributive property. 343, right. Okay, so now I want you guys to look at this one more example. This is kind of like part B in your homework. And see, let me pause this and fix my board. So another problem that you have, a different type of problem, is where you have to go backwards. So Anderson, what do you think that looks like in this picture? What do I mean by going backwards? So I'm going to use the area of the rectangle below, the whole rectangle, or the small rectangles in it, and I'm going to find the missing dimensions and fill in the boxes with my answers. So what's dimension? What does that mean? The word dimension. Yeah, Abby?
Sort of like
Yeah,
size.
shape size. Like in a rectangle, dimensions would be length times width. That's what it means by dimension. So I'm asking you to find the dimension of the big rectangle by finding the missing boxes first, and then write in the dimension of the large rectangle. So how are you going to do that, Anderson? No. Any ideas? But you do have some numbers, okay? So it's a problem. It's a challenge problem that you do have some numbers. So what numbers do you have? And what do they represent? And that's area, right? And you have to get that by multiplying, like, these two numbers together have to give me this answer. Does that help? Why 4?
Because 4 times 5 equals 10.
Okay. So then could I put like 5 here? Put your hands down, let him think it through. Like, he's right, you need a 4 and a 5. My question is, could it be like that? Or does it have to be like this, Anderson? Naomi's just jumped up with an arm here. What? What, Naomi?
It has to be the 4, and that one has to be the 4, because 5 doesn't go into 24.
So you're right, Anderson, it is a 4 and a 5. It could be a 4 and a 5. But if you want whole numbers, you want a number that goes into 20 and into 24 with division. You want a factor of both. A common number. There is more than one correct answer to this problem, but one correct answer is 4 here, 5 here, and Naomi, what goes here? 6. Because 4 times 5 is 20, 4 times 6 is 24. So this whole length then, JT, what is this? How long is that? What do you think, Elsie? How long is that?
Um,
From here
plus 6.
all the way to here, 5 plus 6, right? So 11. So the dimensions of this rectangle is a 4 by 11.
Can you go back to the question for a second?
Yes,
I'm writing that question down.
but it's a great puzzle. Okay, so I'm going to stop there and let's start some of the homework problems together.